All right, hello, my wonderful students. Today's lesson is going to be um, direct instruction. So it's going to be me here teaching you how to do the two-step Stoich problems. Woo! I hope you guys are all doing well and are all safe and healthy. Okay, so before break happened, we were doing single-step Stoich, and those of you that did the summative, you guys crushed it. I was super, super proud. So this is the worksheet that's in April 1st with this video. So how this is going to go is we are going to do the first two problems together as example problems. Then you guys are going to be responsible for doing the other four problems for today's assignment. Okay. Again, remember, I am available for Zoom chats, one-on-one help every day from like 11 to 1. So just let me know what you guys need. All right. So let's get to chemistry. All right. So for each problem, there are two parts. Make sure that you use the answer from part A for part B. So you have to solve for part A before you can do part B. All right. So the first thing is we have to balance our equation. Okay. So again, if we need help with balancing, I'm available for Zoom chat. Let me know what we need. But moving on. All right. So if you notice, there's now two parts to our problem. Okay, so we're going to do part B, okay, and then we're going to use that for part C. So you got to go in order, don't try to skip around. So part B asks how many moles, okay, I got to know how many moles of water are used if there's 3.6 grams of water, okay? So I'm trying to go from grams to moles, okay? So if I'm going from grams to moles, okay, if we have anything that involves grams, you need to use your molar mass, okay? So because I have grams, I'm gonna look at this beautiful piece of paper that I know you guys all miss so much, okay? I have to use my periodic table if I'm going from grams to moles. If you see grams in your equation, you should automatically think molar mass, okay? So the molar mass of water, I have H2O. So I'm going to go ahead and divide out what I have, all right? So I have 2 hydrogens and only 1 oxygen. The molar mass of hydrogen is 1.01. And then the molar mass of oxygen is 16.00. You add those together, and your total molar mass is going to be 18.02. Do not forget your units, kiddos, which is going to be grams equals 1 mole. Sorry if the screen is a little tricky. So now I'm able to solve my problem. All right. So I want to know, so I go ahead and set up my train track. All right. I put my given on top. So I start with 3.6 grams of H2O. Second move is I gotta bring down those units. So my grams of H2O go on the bottom, okay? So I'm gonna go ahead and look over here at my molar mass, all right? My unit of grams is on the bottom, so my 18.02 has to go on the bottom, and my 1 mole of water has to go on the top, okay? So now I want to solve for moles of water. I have moles of water on the top. Get my handy dandy calculator. I'm sure most of you are using your cell phones. And I'm gonna take 3.6 divided by 18.02 because it is on the bottom, okay? And I get this number, okay? I do not need all those decimal places, okay? So I'm only gonna give myself 2 decimal places. So I'm gonna go 0.2. 0 moles of H2O. And again, I'm going to plug it into my calculator because we always double check work a second time. So 3.6 divided by 18.02. Beautiful, right? So Step one, done, okay? But now I am going a step further, okay? I now not only want to know, hey, I start with 3.6 grams of water. I want to know actually my end goal of this whole problem is to figure out how many moles sodium hydroxide were created from that many grams of water, okay? So we're going to use our answer from problem B, okay? So with this, we're now taking it another step. But we're not really doing anything new. You guys have all done this before. We're just now doing 2 steps per problem, okay? So this one here, my given, sorry, little leg. My given is this value right here, okay? So I go ahead and I set up my problem. My given here is 0.20 moles of H2O, okay? I'm gonna go ahead and automatically bring down my unit. Okay, so now if I look at my problem, I'm not going from grams to moles. I am going from moles to moles. So do I need my periodic table for this? No, because I'm not using grams at all. I just need this beautiful balanced equation up here, all right? Because that's all I need when I am going from moles to moles. So I have my moles of water on the bottom. I put the moles of what I'm trying to find on top, trying to find moles of NaOH, okay? And I get my values from my coefficients up top. 2 moles of water, 2 moles of NaOH, okay? And then I go ahead and I solve. Lucky for us, all our values cancel out. And my final answer is 0.20 moles of NaOH. All right, so seems like a lot, okay? It seems like a long problem, but none of this is new. And you guys crushed this last unit, so you're gonna keep crushing this, all right? So just make sure that you are double checking your work and you're going step by step. So we're gonna do one more together as a group. Obviously, if you're like, Miss Edge, this is a piece of cake, I don't need to listen to this anymore, and you want to try the next one by yourself and the last 4 by yourself for your homework, totally fine. All right, but if you're like, I want to see one more, stay tuned. All right, so going down to number 2. Again, if I'm going too quick in these videos, please shoot me an email. I'm obviously not really used to talking to my computer as opposed to talking to you guys. So just let me know. All right, we're gonna change colors so you guys can tell which one is which. All right, so my full problem up top here you can find is how many grams of sodium chloride will be made from 3.65 moles of calcium chloride. Okay, so this is obviously not just a one-stepper anymore because we're not going from grams of sodium chloride to moles of sodium chloride. And we're not going from just like moles to moles, okay? So whenever you see grams of one substance, we'll call him A, going to any form of B, so like grams of A to grams of B, or grams of A to moles of B, you know it's gonna be more than one step. Okay, so obviously first things first, we need to balance, okay? This one's a pretty easy one to balance. You actually just need to put a 2 here because the only things that aren't balanced are the sodium and the chlorine. All right, again, if you need some extra help balancing, what better time than to zoom this edge? Okay, so we're balanced here, all right? And then we're gonna look at our first step of this problem. This is our end goal up here, all right? But it's gonna take more than one step. So my first step, I wanna know how many moles of sodium chloride are created from 3.56 moles of calcium chloride. Okay, so I'm going from moles to moles. So that is an important step, okay? You need to know what units you're going from, and I recommend writing it over on the side just like this. because it's really easy to get confused of like, am I supposed to be using grams? Am I supposed to be using moles? What is happening with that? If you set it to the side and go, oh, I'm going moles to moles, you'll know exactly what you're supposed to be doing, okay? So this one's moles to moles, which means balanced equation. There's no grams. I do not need my periodic table for this. So I'm gonna go ahead and draw my train track. I'm gonna put my 3.56 moles of CaCl2, okay? Gotta do your dance move, bring it down the units. Okay, and I'm trying to go from 2 moles of sodium chloride. So that's what goes on top. Oop. Okay, so then I'm gonna go ahead and look up at my balanced equation. For my balanced equation, there's no coefficient on calcium chloride and there's a 2 for sodium chloride. So when there's no coefficient, it means we only have 1 of them. Okay, and then we have 2 moles of sodium chloride. So then I'm gonna go ahead and plug this into my calculator. So I'm gonna take 3.56 times 2. Okay, it's my answer that I get. Okay, so that means that I have 7.12 moles of NaCl, all right? And the units are also crazy important because you're working with 2 different types of compounds. So make sure your work is really, really organized, all right? So then I gotta do part 2 because we are not done with our original question, okay? I don't know how many grams of sodium chloride I'm gonna make, okay? So the second part is solving for that grams of sodium chloride based off the moles of sodium chloride that we found before. So we're going from moles to grams. Woo, periodic table time, molar mass. I see that magical G, all right? So I have to go pick up my periodic table. You do need your periodic table for this. Zoom. All right, so gonna go ahead and draw out my line. All right, remember your given value is your answer from part B. So 7.12 moles of NaCl. Go ahead and draw my line, which means I have moles of NaCl on the bottom. All right, then I need to use this good old molar mass. Make that a little smaller there. Okay, the molar mass for sodium chloride is going to be the mass of your sodium, which is 22.99, plus the mass of your chlorine, which is 35.45. So you get 58.44 grams equals 1 mole. All right, so we need to plug this in. We have moles on the bottom, which means we only have 1. Okay, and that means our grams go on top, 48.44 grams of NaCl. Means that our final number of grams that can be produced from 3.56 moles of calcium chloride is going to be 7.12 times 58.44. Show you my work right there. Okay, and again, I only want 2 decimal places because that's all you need, okay? So 416.09, and I gotta put my units, ooh, that's a very tiny G, grams of NaCl. So I'm gonna double check my math here really quick. Beautiful, okay. So rest of the worksheet is your assignment for today. Let me know if you have any questions. I hope this works well. If not, let me know. I can try something different. I hope you guys are all doing well. Have a great day.